What's up, guys? Welcome back to Vanover Machine and Repair, and today's video is another exciting one. If you guys love heavy machinery, old iron, and making money with manual equipment, this video is for you. We're going to be making two of these dump truck rollback wheels out of this solid 9-inch hot roll steel. Let me bring you in closer and show you a little bit more of the details. Now, in terms of making these wheels, just a little bit of backstory. I'm working with a company who is rebuilding this 18-wheeler rollback, and last week we made 3 pins for them. 2 of those pins were brand new pins for these wheels. They got those pins welded on, reassembled everything. They actually had some new wheels that they threw on there, and once everything was reassembled, they realized that the diameter on this section was too large and the bed was actually not level. They sent it down the road, but in the interim, they wanted to get some properly dimensioned wheels manufactured so that way they could finish the restoration and everything would be done perfectly. So that's where we come in. We're going to be making that out of a 1045 by 9. This is a 12-inch piece that we will bandsaw cut in half, and that'll be what we make the wheels out of. The only modifications to this design is the customer has asked if we install a mechanism to grease the bushings. Currently, there are not any holes or any grease zerks, so we'll be figuring out that so that way they can have a longer service life on these wheels. Now, in terms of the bushings, these are currently bronze bushings, and luckily McMaster-Carr has standard size bronze bushings, so we won't have to be manufacturing these. However, we do need to be cutting in an oil groove and adding a hole so that we can interface that with our grease setup. So with that being said, the first step is to get this over to the bandsaw to cut it in half and go ahead and start machining. All right, we got the part chucked up in the lathe and indicated very roughly. It doesn't matter too much. There's many ways to do this, but what I'm going to do is face this first, then we can put a center drill in there and center drill it. That'll give us the support we need so we can do some nice heavy turning, and then we'll drill the hole at the end. If we drilled the hole first, then we'd lose our center, and we'd be doing a lot of the roughing sort of with no tailstock support. So we'll go ahead and get this faced off and go from there. All right, now the fun begins. We're ready to do our machining, and we're gonna be doing as much heavy machining as possible, mainly just due to time. So we're gonna start with a new insert, and I have a sample insert that my Coralloy rep gave me to try out, no affiliation, and we're gonna be putting it to work here. CNMG 432 MP, grade is NC 3235. So we'll get to see how good these guys really are. Just make sure everything is tight. And we'll start out with like 300 thousandths, and then we'll go up from there. I know this machine will easily do double that, but we're gonna try to get to a comfortable rate, not me being comfortable, but the machine producing a nice chip and being relatively efficient. And 50 thousandths off the diameter. See, this is not a good match there. Better. Let me slow the feed rate, see if that helps. Dial that back to 400, I might aggressive as I initially wanted, 350, but it's happy. That's what we want. We want it to be happy. Ready to come in here and cut this taper. We have this dimension finalized and this dimension finalized. So the last external step is to go ahead and get this guy cut. So we'll go ahead and do that. Dead on, 9998. Perfect, that gives us a 5 thousandths, 4 to 5 thousandths of crush. I think I'll be able to lift it at this point, hopefully. Well, I know I said I wasn't going to show you making this part, and I'm not, but we were doing some heavy machining, and our chip control today is much better than it was yesterday, and so I thought I'd just show you some heavy machining with a little bit better success than we had on the first part. The first part wasn't bad, but I wasn't 100% happy, and so when I went home, I did some research. Looks like I might have been running a little fast on the RPM, and so the first cut today was 400 thousandths. And we're getting good chip control. Now these chips are a little bit stringy, meaning I would like them to be shorter, but the machine sounds happier, the cut is very deep, and overall I think we're heading in the right direction. So we're going to continue just doing some heavy cutting. We're probably going to step up the feed rate to shorten these chips, and we might even bring it up to 500 thousandths, because I know this machine will do 500 thousandths all day long. And really, yesterday I was running 500 thousandths at points, but I could just tell the machine wasn't happy. We still have that same insert in there, by the way. I haven't changed it out, so I would say it's doing very well. So with that being said, let's jump in here. We took 400, we're going to take 450. Same feed rate, I have zero idea what it is, but we're running 200 RPM today. I think we were running like 275 yesterday. So this is 450 off the diameter. Same insert. Not bad, we'll finish it out and we'll do 500. All right, not bad. Again, that was 450. So we're going to do 500. I feel like that wants to go faster. 500 thousandths. There it is. Clearly it can do it. The chips are a little short. I would kind of like them to be a little longer, and the surface finish isn't quite as good, so I'm going to step it down slightly. See if we can get a little bigger, longer chip, not these midget chips, and also maybe improve the surface finish slightly. Fall down, they're not hitting us, we're getting a deep cut, we're efficient. I'm happy with that. Very good, very good. All right, now that we have these things both done, we're going to move on to the next step, which is working on the other side. So here's an example of the other side. We're going to get these guys flipped over and machine this on both parts, and then we're going to come in here and add a hole that's tapped for a Zerk fitting. So I haven't figured out exactly how I want to do that yet, but my initial thought is to take and drill a hole at an angle, and then put a circuit fitting in this hub area here at an angle, but we'll kind of see when we get to that point. So first step is to mimic this backside on both parts. Not bad for a 3-jaw with some copper pads. That's 2.5 thousandths. That'll work great. We'll use this from here on out. We got both wheels done and they're looking stellar. Surface finish is great, dimensions fairly good. Overall, very happy with how this is turning out. The next step is to work on the bushings. Now these bores are about 5 or 6 thousandths undersized, which will be a really nice press for these bronze bushings. But I do want to add some oil grooves. And then we also need to just skin the ID of this bushing. It's sized to be nominal once pressed. However, I made the shafts that these are going on and it'll be a little tight, so we're just going to skim maybe 5 or 10 thousandths off the inner diameter. And then once that's done, we are going to install the grease fittings and drill a cross hole so that way they can grease these wheels when they're installed. So let's head over to the lathe and work on the oil grooves. We have this set to an extremely aggressive feed. I have a radius cutter here and we're gonna just thread these in one direction on number 1. And then once we get that to depth, we'll go to number 2 and go from there. All right, working on number 2. The pattern isn't exactly what I was thinking, but it'll work for this job. All right, let's get these bushings pressed in. We're using the 25-ton mode on the arbor press. If this does not work, luckily we have a brand new tool that we can use that will 100% do this. But we're going to give it a try in this machine first. It's working good, so we'll stick with this tool. This is a really nice press. It's going in, but it isn't going to spin, which is great. It's taking a decent amount of force, all 25 tons basically. There she is. One down, one to go. The last step of the project is to go ahead and drill the holes and install the grease fittings. Now, previously the factory wheels did not have grease fittings, and I've talked to the customer and he wants to put the grease fittings on the inner part of the wheel, but in order to make sure that nothing rubs, we are going to recess these fittings. And I think the best way to accomplish this without removing the least amount of material from the actual wheels is to go ahead and come in here and drill a hole at an angle, counterbore that hole, and that will allow you to access the grease fitting. It'll be beneath the surface and it should get us grease to the middle of the bushing. So I got everything indicated and set up. We're going to do these in 2 operations. We'll come in here and create a flat spot, then we'll drill our hole, and then we'll finish up with the counterbore. All right, guys, we're gonna do a little bit of chatting, and I know that most of you guys probably haven't made it this far into the video, so that's totally fine. This is for the true die-hard fans. We just edited the line boring video on the 963, and I did a 26-minute talking section at the end that I thought no one would watch, and surprisingly, a lot of people said that was the best part of the video because we went over the mistakes, what we learned, and I thought, you know what, as I'm learning myself, learning the business, learning the channel, I think that's something that I bring to the table that is definitely unique to me, and that is that I try to be honest, I try to be open, and I try to be real. And I think online a lot of people try to tend to give a perfect persona, and I want to share reality. And the reason I want to do that is I want this to be an encouragement for those people that want to do this or step out on their own and try something new, so they can know realistically how it is, so that they don't have a false sense of what it's like. And then for anyone who just wants to learn and learn from my mistakes, you know, it's the best way to learn. This talking time is excellent for that. It's not great for YouTube content, but it's great for people who really do care. So I figured I'd take some time and just talk about this job and about a couple of other things. So in general, this job went pretty smooth. There weren't a lot of hiccups. Overall, I'm fairly comfortable on the lathe. I've gotten better and better in my skills, and overall, I'm pretty good with that. The one thing that we did sort of make a mistake on, even though it's not a mistake per se, it's just different than I wanted it, is the bushings. What I wanted to do is I wanted to do sort of a cross weave pattern on the bushings, and without getting into too much detail, I actually have my lathe set up with a custom metric set of gears, which we'll talk about in a later video. But as a result, my lead screw, I don't know the feed rate because I have only approximated the basic gear ratios for threading, but I haven't done the math to figure out the feed rate. So on the feed rate, I'm just kind of going off the gut. But my point with that is because I've turned this into metric, when I step all the way up into the most aggressive feed, I'm doing about 20 millimeters per inch or per revolution, which is pretty aggressive, a lot more aggressive than it was in the SAE mode. And so that works out perfectly for the oil grooves, but I think there's a little bit of error set up because I've converted it to metric. And so I was hoping that I could come in here, use the threading dial and use number 1 over and over, cut the grooves deeper and deeper, and then reverse it and use number 1 over and over and come back and kind of create a pattern. But what ended up happening is every time I landed the threading dial on number 1, I actually started in a different spot, kind of like a multi-start thread. And I'm kind of guessing, I know you'll correct me down below if I'm wrong, but I think typically when you're threading metric, you need to leave the half nuts engaged. And I think that's what was going on here. Because I wasn't doing that, I think there was a little bit of error either in the gear train slop or something. And so every time I started, I wanted to do 1 line, but I got 3. And so instead of do 1 bushing correct and learn and do the other one incorrect, I decided to make them match so that they looked intentional. And so they both look good, they'll both function good, but I think in the future that would work fine as long as I leave the half nut engaged, use the reversing feature, and then I could have basically just had 1 line and then reversed the spindle and done it the other way. So that was kind of something I didn't expect, but that was the first time doing that with this setup, and really the first time cutting oil grooves in general. Not something that I've done. So that's a little bit about that. Overall, other than that, the job turned out really, really good. As you kind of have picked up on, I was really trying to dial in my feeds, mostly for efficiency because we were removing a lot of metal, but also just to push the machine. There's like a range where I can get the inserts to do a heavy amount of cutting, get a decent surface finish, and move quickly. And actually on the first one, the one that I showed you, it wasn't quite as good as the second one where I kind of learned a little bit, and so that's why I kind of showed a little bit more of the second one once we got those speeds and feeds dialed in. But other than that, it's a pretty straightforward job. I will say on these bigger jobs, it seems like our jobs are getting bigger and bigger. Really, a lot of time and effort goes into material handling, cutting the material, heavy hogging, drilling heavy holes. The actual complexity in the machining isn't there, but you just spend a lot more time than you think just due to the nature of metal removal and working with the part. So that's something that I'm sure I'll become more comfortable with, but these are probably some of the bigger parts that I've made, and hopefully they'll just keep getting bigger and bigger. I have a passion for bigger parts, but you know, we haven't had the need, and so we're moving in that direction. So in terms of this job, that's what I'm going to say about that. Overall, it was really a success, not too many gotchas. The other thing I want to talk about is I'm getting a little bit sentimental over here. If you notice behind me, the lathe is somewhat cleaned up. I actually, in the last 3 months, this lathe doesn't have a chip pan, so basically I let the chips fall, and after doing this job, the chips had piled up almost level with the bed so that they weren't draining in the back, and I ended up picking up a couple 55-gallon drums and taking the chips and putting them in the drum, which is very basic. That's what you do at a normal machine shop. But to be frank, every year that we've been doing work, machining-wise, we've been doing more and more work. And I'm in year 4, and in 4 years, I haven't really been able to fill a 55-gallon drum in a reasonable amount of time. And what I mean by that is typically what I'll do is I'll do a couple machining jobs, I'll take the metal chips and I'll throw them in the trash. It's not the best, but there's not really enough to recycle, and so I pair it with my trash. We have a bunch of dumpsters out back, and it is what it is. But in the last 3 months, we've been doing a lot more machining work, which is excellent. And so we got to the point that I started to have so many chips that it just doesn't make sense to throw them away. It really makes sense to maybe recycle them, or at least at a minimum, basically put them into large containers so I can at least scrap them or something, because it's really too much at this point for the trash. And to me, that's really exciting. I don't want, as much as I would like to pretend that I'm this full-blown machine shop that has everything figured out, that just isn't the case, guys. I'm getting there and I'm growing, and I want to be thorough and honest with you guys about that. You know, in year 1, we didn't have a lot of work. Year 2 is a little more, year 3. And really in the last 6 months, we've really gained a lot of new clients and customers, and we're really getting to the point where we're starting to really be doing a lot of machining on a day-to-day basis. A year ago, I probably spent, 5 hours a week on customer jobs, a lot of time on my own machines, and a lot of time doing other type of work. And in the last 3 months, I've been spending 20, maybe 30 hours a week machining, which is excellent. And I'm sure it will increase as time goes on. And so I'm really excited about that, and I'm very grateful for the ability to do these jobs and to be able to do more jobs. But I want to share that with you because I was having a sentimental moment. Basically 4 years in, I'm starting to collect my chips in a recycling bin, kind of like a real machine shop. And so to me, that's a really cool thing. And it's cool to be getting there. I know it seems like that may have taken a long time, but that's kind of how this business goes. It's not like you can just get a mill or a lathe and overnight be slammed busy. It's taken a lot of work to get this point. And today it's Sunday. I got these done yesterday on Saturday, and I came in today. I work on Sundays a lot, and basically spent the whole day cleaning up chips, cleaning up the shop, just from all the jobs that we've had this week. Trying to put in the extra hours so that we can keep the videos flowing, we can keep the jobs going, keep the customers happy, and try to keep somewhat of a balance in my life, even though we are working a lot. So I just want to share that with you guys about where we're at and where I'm hoping to go. Again, I have a passion for machining, and specifically heavy machining and doing larger jobs and bigger machines. And so I'm hoping that as time goes on, we can really show you guys some really nice, big, beefy jobs, big shafts, big parts, heavy cuts, some really, really cool stuff. And of course, this machine can do a lot of great work, but the Lion is even bigger, and we're really going to push that machine, and it's going to be really awesome. And hopefully you guys will be here along that journey. So with all that being said, I hope you guys have enjoyed, just a little bit of chatting there. And if you guys have any questions or concerns, I'm going to do my best to continue bringing you these videos. And I keep going back and forth on, should we give more commentary? Should we do less commentary? And at the end of the day, you know what? I know that the people that care about the commentary, it really benefits them. And so this may be a better way to do it, where I try to machine and keep the talking to a minimum, and then most people can watch that. And then towards the end of the video, people like me who like to talk a lot and people who like to learn can stick around and kind of get the extra information without having to kind of drag on. But we'll see how it goes. I'm always experimenting and always trying to do something unique and new, and I like to keep it fresh. So yeah, that's pretty much all I want to say. I appreciate you guys commenting. I appreciate you guys sticking with me. I know there's a couple of you commenters who just show up every week, and I'm just super grateful for that. It definitely keeps me the energy to keep going, and we will keep doing that. So with all that, we will see you guys next week for the next video.